Greetings and namaste. I am Narayanan Komerath. My co-authors are Satyajit Meti, Rohan Ramachandran and Ravi Deepak. We are aerospace engineers seeking help from the meteorology community to implement a new capability. Global warming and sea level rise can be stopped and reversed. The technology is there. However, the risks in any climate modification can be alleviated only through reliable predictions. Such predictions need data, massive amounts of data. We can provide such data with your participation. The top left chart from NASA shows data taken at the top of the atmosphere, spacecraft, accounting for heat from the sun and heat radiation from Earth. The average is not at zero. There is a net heat retention rate by Earth. The present value is 0.82 watts per square meter of Earth's surface, and it's rising. This is global warming. The upper right graph shows sea level rise since 1880. It has risen about 250 millimeters, a quarter of a meter, and it is accelerating. The bottom graph goes back millions of years, and you see that there is enough water somewhere on Earth to raise sea level 400 meters above where it is now. So the problem is very real. How do we counter it? Planting trees is a good move, but beyond that, what? Increase Earth's reflection of sunlight. You will see more and more dramatic news items about geoengineering. The problem is that we cannot predict what will happen if someone does something drastic, even if it looks logically safe. And if something happens that is totally unrelated, these people will invariably get the blame. So the UN and the US National Academies have laid down strict guidelines for any such efforts, and we are happy about those guidelines. To my knowledge, ours is the only approach or architecture where the guidelines are a natural part. Over the past 8 years, we have developed a concept called glitter belt. That is what may be seen from far above, 1,000 points of light, as President Bush used to say, probably hundreds of millions of points of light. It cannot be seen from the ground. It is to put up millions of reflectors in 30 years, mostly from nations of the global south, that will stay airborne in the mid-stratosphere, reflecting a tiny percentage of sunlight. This will not be monopolized by anybody. It really cannot be monopolized by anyone. It requires a global effort. They will move with the summer sun and not be stationary over any one place. How is this to be done? We have just two types of vehicles: flying leaflets that are launched from anywhere like a cricket field or a beach. 6 out of every 9 leaflets comes back down the same day after delivering a reflective sheet and frame to assemble a large flying leaf in flight at high altitude. The other 3 will be left up there to propel the flying leaf. Both the leaflets and the leaves will continuously map weather and surface phenomena over the entire planet. The leaves stay up indefinitely. The leaflets return by sundown each day. The first rule is open, scientific, peer-reviewed publication. We have some 30 publications, of which 23 are peer-reviewed. The others are in pretty scary conferences as well, and public outreach. In 2022, an expanded version of our paper that was presented at a major climate plus energy conference was published by the journal Applied Energy. For the first time, we laid out the full scope and cost of not just slowing down climate change, but actually stopping it and reversing it to the level of 1990 by the year 2056, if we start soon. The blue line is the number of high-altitude flying leaf reflectors operating in any year. The red line is the number of flying leaflets that have to be manufactured each year to do this. Yes, large number, many years, but totally controlled. And if you look at the number of, say, Toyota automobiles manufactured each year, you'll realize that this is really not even very ambitious. It's quite doable. Let us now see a movie. These are from scientific flight simulation. The scenery may not be pretty, but the dynamics are modeled correctly, and the sunlight is modeled correctly. The 8-meter span Kavaratti flying leaflet is a solar-powered biplane. It can take off and land on any surface, but also fly 400 kilometers during a day. As we'll see in a moment, it is intended to go around the South Indian coast and then fly across to Kavaratti in a single day from Chavakad or Kochi or Amritapuri, and then do routine meteorology around the Lakshadweep Sea and then later the Andaman Sea, do microclimates and remote sensing, then flying leaves south towards the Tropic of Capricorn or Antarctic Circle and back up north. It can do rendezvous to build large flying leaf vehicles that can cruise during the daytime at 30.5 kilometer altitude, where sunlight is essentially the same intensity as in space, form swarms to do this. And from dusk until dawn, glide and still be above 18 kilometers when the sun comes up again. Our peer-reviewed publications cover every phase of concept development, public policy, economics, ground testing, flight testing, model design, and flight simulation. The more recent publications over the past year are with Indian undergraduate students at Indian conferences as well as American Meteorological Society conference. Why not your students and yourselves? You're most welcome. It's your planet. Risk reduction requires reliable prediction. Correlation with reality has improved over the past 40 years, as you can see from that graph on the left with the blue, green, etc. Blotches of ink. The uncertainty has reduced, but present meteorology cannot really predict with better than 60% correlation beyond 7 days. That is detailed rain type of prediction. We are more interested in what happens to ocean currents and the monsoon and things like that on a grander scale. 50% correlation is a coin toss, remember. So there has to be a major advance in meteorological prediction, and NOAA, the National Oceanographic and Atmospheric Administration in the USA, is asking for 100 times increase in high-performance computing resources in the next decade. There is a circular problem. If you develop a solution for global warming, you must have predictions confirming A, that it will be effective, that it will work, and B, that no bad effect will occur, say in 5 to 10 years. To develop such detailed predictions, you need detailed data. Weather prediction, like stock market prediction, works best if you predict yesterday's results, not tomorrow's results. I may be kidding there, but how can you get such data over the remote oceans? Satellites are far too high, 400 kilometers for low Earth orbit, moving at 7.5 kilometers per second, or geostationary at 36,000 kilometers up. Our glitter belt is at 30 kilometers and can loiter over an area. Our data will be measured using the same craft that we use to reflect sunlight. Meteorology is part of our project from the very beginning. E-plane company near IIT Madras is building a 2-meter model weighing only 1.5 kilogram force. That one is battery powered, radio controlled. Next level is a 4-meter model. Hope E-plane builds that one too. That will start as battery powered and evolve into solar powered, beyond visual range, autonomous, able to fly high for a whole day in the sunlight. It can test meteorology. The next level is full scale, 8 meters. The Kavaratti vehicle used to build 72-meter span flying leaf vehicles, also for routine climate mapping. Here are some suggestions for meteorology applications. I'm beginning to learn about what has been done in this area and can certainly benefit from your guidance. So we need your help. Here are some suggestions. This is here, today. Don't wait for somebody else to do this and then admire it on WhatsApp. And please get your students to participate and help us build the models, develop payloads and experiments, analyze data. Think what things you can measure. We want people who are interested in building UAV models, in getting publications. We need participation to bring the Coast Guard and Navy on board, the people in the Lakshadweep, the fishing community to access beaches and fish our craft out of the water if they fall in. This is a community effort. This is our future. Thank you.